Okay, good morning all together. Thank you for participating this webinar of today, Mastering the Testing of HEPA ULPA Filter Quality. My name is Martin Schmidt. I'm a production manager at the, I'm product manager for the I&S department of the Padas company. The I&S department includes aerosol generation devices, aerosol measurement devices, nanoparticle devices, and all types of measurement, but as well filter test rigs. And that's the topic of today, what I would like to join you. So thank you again for joining this webinar. Welcome, I hope you will enjoy it. And yeah, just before I start right away, this is a one-line webinar, meaning I will present you our LFT system and tell you about the standards and different tasks there. But you can put questions in between in the chat. Please, if you have questions during this webinar, use the chat to ask your questions. But I can answer them just after the webinar is finished. So I hope we can start with that. So I take the camera out of the window again. And let's start. LFT system, mastering the testing of HEPA ULPA filter quality. I will start with a short introduction. Give you a little bit an overview about the appropriate standard 29463 for HEPA ULPA filters. And then I will come down to the leaked filter testing systems, showing you how the whole system works, what software is included, what measurement results you can expect. And at the end, I will come to a conclusion. So just to start with the introduction for sure, filter element testing. Yeah, I used that slide in the previous webinars as well. I like it very much. If in case you joined the last webinar about the FET system overall efficiency of 29463 part 5, you have seen it already, but I like it. I was just Googling last year filter elements, and yeah, that's what I got. It's a screenshot more or less out of Google. And what you see here, one of the difficulties in filter element testing, it's more or less, you have many different shapes of elements, you have many different sizes. They're expected to run at different airflows with different aerosols. They're done for different applications, meaning as well they are testing in different ways. So what can we do with this many different types and applications of filters? Usually, just here, a short overview about the most common ones. We have standards for general ventilation filters. They are graded in MERV grades in the US, in ASHRAE 52.2, or in EPM-X, EPM 2.5, EPM 10, and EPM 1 values in ISO 16890. EN 779 here, right on the left-hand side, is rejected now. I have it in here because the G and F filter classes are very common in usual use. We have cabin air filters, ISO 11155, or the German standard EIN 71460, very close together. We have engine filter testing, blow-by filter testing, compressed air filter testing, cleanable filter media testing, and one very big application, huge range, is EPA, HEPA, ULPA filter testing. And this is described in 29463, ISO 29463. And this is our topic of today, how to do these tests and how to perform quality during the whole standard procedure, how to test quality, how to ensure quality with your HEPA and ULPA filter elements. What is needed commonly to test HEPA filters? Quick testing. It should be fast. The testing must be done according to the standard 29463 part 4 and 5 for the complete element. And for sure, if you're talking about quality, you will need a higher repeatability. That's necessary. You need a long lifetime of the test rig itself, easy operation for sure. You need to quickly change your filter elements. It must be test rig which is really operating all time. The setup for sure must now be customized because every manufacturer has different size of elements, a different product range to test. And so these test rigs really can be economically designed to the requirements of the manufacturer, who does what filter and what is needed to ensure the quality of these filter elements. So basis, as I said, is ISO 29463. And here I want to start with an overview because ISO 29463 is quite large because it contains 5 parts. Don't worry, it's not too difficult. Part 1, ISO 29463 part 1, is giving the classification, performance, testing, and marking indications during quality control of the filter elements. Or it's still valid DIN EN 1822-1 from 2019, which is doing the same thing, but the classification is different. And I will show you the differences a little bit in the next slides. Then we have second part of 29463, part 2. It's the requirements about aerosol production, measurement equipment, particle counting statistics, and other things which are important for the measurement. A very important part because in designing such a test rigs, you have to look at the borders and requirements of the measuring equipment used in such a filter tester. Part 3, 29463 part 3, is describing now how to test the flat sheet filter media, so the material the filter is made of. It's dated from 2011. Part 4 is then a quality test method. This is done to determine leakages of the full filter elements now, not the material. Now we have the complete elements. It describes a scanning method to be used to detect now local leakages at the filter elements. By doing so, if you ensure the quality locally, you can ensure as well the quality of the full filter element. That's part 5. This one describes then the test method of the overall efficiency for the full filter element. Yeah, so that's more or less the overview. So it's meaning, first of all, we can take care about the classification of the filter elements, and there we have something what is now inside since several years, but maybe not that much used up to now, or not so common. As you know it, it's the classification of the filter groups in the ISO standard 29463 part 1. You see here it's starting at an overall efficiency for the complete element of 95% or a penetration of less than 5%. Penetration and efficiency is close together. Efficiency describes what is held back by the filter element, and penetration describes what is going through the filter element. So in other words, if we're talking about percentage, we could say here in our example of the ISO 15E, efficiency is higher than 95%, and efficiency is then, as an equation, 100% minus 5% of penetration. So that's how they fit together. What you see here is now, it goes up in steps of, here 4%, and then it's 10, factor 10. Here, always 19 more in efficiency describes the different classes. And in the past, these steps were a little too long. So in ISO, we have different steps in between. You see here additional classes where you then have the requirements just in between. I just couldn't put that on one sheet because it was a little too small for that. That's the overall value. That is really the overall efficiency of the element, what it has to achieve in testing in case you have a certain qualification. The second point, what is described in the standard, is then related to ISO 29463 part 4, topic of today. It's the local value. That's called local value of efficiency and penetration. And you see here for the E-class filters, you don't have any local value, meaning you don't need to test E-class filters concerning local efficiency or penetration. Locally, again, means we scan the whole filter and looking on local areas on the efficiency of the filter. I will show you that later on more in a better way. So above class ISO 40 or ISO 35, that's the HEPA filters, you need to detect as well the local value, meaning you need to look at the complete filter if there is any leakage at any point. And there we have a different definition for the local efficiency. You can see the local value is a little smaller than the overall value. And this local value must be kept as well. So at the end, to have a certain classification as an ISO 35H filter, it needs to have to pass the overall efficiency test, so it must be above 99.95% efficiency, and locally it must be above 99.75% efficiency. So that's the two tasks you have to admit in case you want to classify a filter according to the ISO standard. So EN 1822 part 1, and for those who are longer time in filter testing and in the filter business, you see here, we have the filter classes according to EN 1822 part 1. It's the E filter classes here, E10, E11, E12, and here you have the HEPA classes, H13, H14, and the ULPA classes, U15, U16, U17. That's very common numbers for sure, in case you have a test trick for quality control. This test trick should as well implement the filter classes of EN 1822 part 1, which is still valid. But you have see here as well, we have here for the E filters still the overall value, but for efficiency and penetration of local values, there is no limit, so you don't need to leak test the E filter classes. Just the H and U filter classes need to have a certain local value as well, so you need to avoid to have any leaks in your filter element. ISO 29463 states that any HEPA and ULPA filter element needs to be scan tested, needs to be tested for local leakage in case this is possible, and there are more than one possibility to do it. But first of all, what is needed to know about your filter element is something about the material, and that is described in ISO 29463 part 3. On the material, on the flat sheet, you measure efficiency by particle size to detect the so-called MPPS. MPPS means most penetrating particle size. So in case we are looking at an efficiency curve, and here I have an example out of the standard, you see here we have the diameter of the particles, and here we have the efficiency on the particles on display, and you see a typical curve going here. So for very small particles, you have high efficiencies, usually caused by diffusion effects. Then particles grow, diffusion effects go down because the particles become more weight. And then it's going down the efficiency, and then it starts to have separation by forces, so means by impaction. And you see here at the very lowest point of efficiency of such a filter, you have the lowest point of efficiency by diffusion and the lowest point of efficiency by impaction. But in case the particle size grows, this one is going up again. And so the forces by impaction are coming up because the particles are more heavy. So task of part 3 at the flat sheet media, at the particle material, is to detect where this minimum point of efficiency is and what efficiency you will achieve here because later on, in case we test the full element, we have two tasks. One task is that the particle size distribution of the test aerosol is here somewhere where the local minimum is of the filter material. And the second point is that we exactly know where it should be, and we have the possibility then to do a quicker test. So where do you get this information as a manufacturer of filter elements? Usually quite easy in case you buy your filter media. Usually the manufacturer will provide this data to you, meaning he provides the information where is the MPPS, and so the particle size where the MPPS really is. Sorry, my mouse is a little bit noisy. Here, in that case, 0.16 micrometer. And then for sure, the efficiency itself, 99.9975%. So this would give you as a manufacturer or the manufacturer itself the possibility of looking if the test rig, how the filter element test has to be done. So afterwards, we look now for the local efficiency and the overall efficiency. Local efficiency, as said, is described in ISO 29463 part 4. The test method to determine leakage, the filter elements scan method. So what is done? More or less, the filter is challenged with the test aerosol, and you have a sampling probe connected to a particle counter downstream, so on the clean side of the filter, which is now scanning along the filter and detecting the output of particles counts. In case you have a constant upstream concentration, you can calculate from the local value here, if the probe is here and here and here and here, how many particles are coming through, and therefore just calculate the efficiency at each single point of the filter element in downstream. Like this. This would cover part 4. So in case the local value is not exceeded during that scan, you have passed the first part of the test and you can classify your filter. For part 5, test method for filter elements of the overall value, that's a different part usually, because it describes just to test the overall value and not the local value. But here it's quite practical in that case of the scanning. In case you're scanning for a local point to test overall efficiency with the scanning procedure, you can take all the locally detected particles here, what you got with your sampling probe on each different point, sum that up, do the mean of it, and with regard to the scanning time and upstream concentration, you're able to calculate the overall value as well in the test procedure according to 29463 part 4. How that can be realized is now the next part of our webinar. So LFT 3000, this design came more or less from a customer from us. It's regarding customized filter testing. So their requirement, it's mega filter in Turkey here. As an example, out of our product range, they want to test HEPA filters according to 29463 part 4 and 5. They want to have automatic scanning, meaning not going by hand with a probe across the filter, but everything automated concerning scanning. They have certain filter element dimensions mentioned here, ranging from 305 times 305 millimeters up to 610 by 1220 millimeters. Height, depth could be 50 to 300 millimeters. So airflow range approximately 100 meter cube per hour. So the rated airflow for the filter elements up to 1200 meter cube per hour, and the scanning speed, according to the standard, maximum is 10 centimeters per second, but for sure you want to increase speed to be as fast as possible and having all filter elements what your manufacturer tested in the same day. They wanted as well a flat sheet media option, test option, maybe analog to 29463 part 3, just to check the quality as well of the incoming material, which can avoid for sure manufacturing an element with a material of not good quality would lead to the fact you have a lot of work and you can't really have the elements in the right filter class because the material was too low in efficiency. So together we have designed, and was very good relationship here, the scanning test rig LFT airflow, here in our case 100 to 1200 meter cube per hour. For sure, you see here it's divided, the whole testing system is divided in two parts. One part is the suction unit. It includes the blower. You see here the electrical cabinet. For the blower, it includes the airflow measurement and all of that. HEPA inlet filtration and whatever you think, and you can have a tubing here in between to connect it to the scanning unit itself. For this here on this side, it's the test section where your HEPA filter is installed, and we have the scanning probe to move. It's automated, as I mentioned. Aerosol generation measurement is done above 0.1 micron. So we are scanning according to the standard from 0.1 to 0.2 and 0.2 to 0.3 micrometer. So what is now really the advantage of that setup? First of all, as I mentioned, we have this suction unit with blower and flow control. The airflow system rate measurement is in there, inlet filters, pump assembly, and so on. And one really good point of that is the separation is we can have several blower units at one scanning unit, or we can design according to your request the blower unit for different airflows. Up to 5,000 meter cube per hour was the last one we offered here. And this is really not a big thing, because we have here independent airflow suction control, and we can have here multiple elements just to add to the scanning unit. And so we are very flexible here as well. If you have wishes to, for example, you have an existing scanning unit and you wish to change the airflow later, we can offer you a different blower unit, just easily connected then to your scanning unit. It's a very exact airflow measurement and control inside. It's a separate unit, yeah, with the connection tube. It's including the electrical power supply cabinet as well. So individual configurations are possible here. And then we can switch to the leak testing unit. So it's done in compliance to 29463 part 4. It's a leakage filter tester. It's making automatic leak testing with an optical particle counter integrated. You see here the sampling probe, which is moving then across the filter element, which is located in here. Here you can see one of the larger filter elements. It's a testing hood, which covers up to 610 by 1220 millimeters. You can have others on request here, the same thing for sure. We can build that larger, or we can build it smaller, depending on the product range of filter elements you're having. It's computer controlled. It allows an easy exchange of the filter and filter adapter plates. In case you have questions there, I can show you some videos, but I think today for the webinar, this is a little too much. It's a testing traverse system where yeah, you have a downstream movable sampling probe and an XY coordinating system, so showing you the exact place of the probe all the time. Remote particle counter is built in with dilution unit for upstream measurements, and switching system that's automated, so the measurement starts here with that type of counter at 0.1 micron, or from 0.3 micron would be possible as well. And for sure, we can add to increase scanning speed more than one counter, meaning we have 2, 3, 4, indeed, if you want 5 sampling probes connected to the system to have a higher speed of scanning then. The safety protection cabinet is out here. You see it in case the fixtures of the element, which are pneumatical, you can just use them or activate them in case the whole cabinet is closed for the safety of the operators. So open these doors means stopping any pneumatical actions, not to have injuries by the operators. So it's well fixed. And it's computer controlled, the whole thing for sure, to operate the test bench via an intuitive touchscreen, what you can see here. And this is including as well the software, the reporting software, the control software, and so on, to move the probe to see leakages and whatever. So leakage filter testing system, here you have an inside view now. Here you can see it, the inside view. And you see here as well the sampling probe, which is installed. Here you have the pneumatic installation of the filter element. You can see it here. And so we have additional adapters around here. They are fixed with the bars on these sides, so to fit as well the different filter elements easily into the test system. The exchange of these adapter plates, which are used for the different sizes of the filters, is quite quick. It will take you maybe 5 minutes to adjust, to put a new adapter in, and the fixture of the element is, in case the adapter is inside, there are spacers and everything installed to fix the element. So that's approximately 1 to 2 minutes. So it's easy to fix. It's the height of the scanning probe is adjustable here to have different heights of filter elements enclosed, and as soon as the filter element is then really inside, the software takes over. So I will show you that procedure. You just select your filter class, you select your settings for the filter test, and then you start. And for sure, it will then start with the scanning. I hope you can see that, and it's coming over. So then the probe is moving automatically to scan the filter areas. Probe size here is 9 centimeters times 1 centimeters to cover a large area. So you can increase speed. That's very statistical, well done scanning. So taking a longer time, but you can increase speed at up to 10 centimeters per second. And then it is much quicker to get now the leakage detected. Here you see it, it's continuously sucking through the probe, and so you can continuously get particle counts and see in case the particle number concentration exceeds the limit as given by the standard and calculated from the upstream concentration. It will be detected, and you get a nice view out to see where the leakage is, in case there is any, and meaning you have the ideal information then maybe to seal the leak, or the filter passed anyway, what is most commonly case, and then you can just have the automatic printout of your test report. So it's possible to operate that test rig just with one person. That's quite easy. And yeah, part of that is the software, and we were very open to that to help you as well if you have different requirements there with solutions, software solutions, what we can do and to help you. Currently, starting such a filter test, I mentioned that in the slide before. You just starting here with a screen, you load the settings here. With load settings, you load your settings of the filter you want to test. Here it's an H14 610 by 610, and it gives you automatically where the filter is placed. Here you can see that in the blue screen in here. Here is the location, current location of the sampling probe. Here you have the lower left corner of the filter element and the upper right corner. This is already prepared and implemented, and you just can move now the probe, which is here, just by clicking on one space on the screen. You have here automatically loaded as well the settings, like your main airflow, that's the nominal airflow of the filter element. The ideal setting for the aerosol generator concerning concentration, it's an airflow through the generator, which is tested. The delay time itself means it's the time of the location, current location of the sampling probe, which is taken until it reaches the particle counter at the end. That's the delay time. That is necessary now to detect exactly where the leak later on really is. And you have here the speed in millimeters per second, as mentioned. that was the video as well. That was 20 millimeters per second, so 2 centimeters per second scanning speed. We can increase it up to 10 centimeters per second. So everything is automated here and can be calculated as well by the operator. So the main operator can here as well adjust settings in case he needs to do that. So second part is then entry of the serial number of the filter element, of the filter dimensions. You can select that out of a click. So here we have as well the point load settings, and you load the predefined information just in, and you just add the tester and the serial number of the filter, and that's it. For sure, we can talk about adding the serial number as well, like by a scanning method or whatever you want here. So then you select the filter class for the test. Here you can select the different filter classes, and then you just press start test. So for sure, and that's always a part which Pallas is very important for Pallas, we want to have a high repeatability of the tests. So what follows is then for sure we control shortly each of the test parameters. It means the stability of the main airflow, the stability of the aerosol generator flow. You see it here in some pictures, they come up automatically. Fan is increased and you see fan is stabilized. The particle generator has started and measures upstream concentration, and it's stabilized here up, and then it measures upstream data. That's just in case just one counter is used in the whole system. In case it's more than one counter, we can use as well one counter for simultaneously upstream concentration measurement. Then this would not take place. It's taking place as soon as the test starts, so as soon as the scanning starts. That's for 2 or more counter versions. For sure, counters can be, additional counters may be installed as well afterwards. So then the scanning starts. You can see it here. So the probe moves now up and down here through, as you have seen it, through the whole filter area. And you can now see here, for example, and that's something special, we have a small leak in here just for demonstration. Here you can see now the border of particle counts, here 229. That's the border coming from the standard for related to the upstream concentration for the number of counts, which gives you a leak or not. That's a strict border, 229. So what you can do additionally here in the software, we defined, you know, a yellow mark place, for example, that's for local penetration, which is very close to the point of no return, I would say, to the point of leakage. You see, very close. So it means this yellow marked is a local penetration, which is 10% below the leak. So close to the border, but still fulfilling all the requirements. And then we have another orange marked local penetration, which is then 20% below the leak point, below the maximum point. So this is as well done for R&D and development to see how close you are to the overall to the local efficiency. In case you detected a leak, now green, sorry, I forgot green, is then a local penetration which is more than 20% below the leak. So it's allowing R&D to optimize for sure the manufacturing process and have a look at critical points additionally. So for all of that, for the whole scanning here, it was not finished. Because of that, the remaining part here is white. In case now you have done it, you get your result screen. Test is finished now, you can see it. And in case you have detected a local leak, like it is done here, you can just click on the leak, and the sampling probe now automatically moves to that point. You get indication here of overall efficiency and the efficiency with the 95% statistical value. Indeed, that 95% efficiency, I call it like that, is a statistical value. So it's approximately 5% below the overall efficiency. And it's meaning it's just for statistical requirements to ensure quality. It's giving you a statistical point where you say, okay, that's now really the point where it should be. That's described in the standard. So that ensures that the quality is really above 99.99% or above the value you have indicated for your filter class. So simple click means you drive to the leakage point, you can seal it, and then start the test again. After the test is then finished and all is green, I don't have that screen right now, not because we didn't have the filters, just to be a little quicker. You get automatically a test report that was as well agreed with the customer. You can see it here. You can put your logo on the test report. You give you that possibility here. Not a problem for that. It's automatically issued and printed out. Optional, we have a report for flat sheet media testing if you take that option as well. It includes all necessary information. It's a one-pager in that case. For sure, the individual reports can have much more information, but that's the main information you have here. All the information about the filter data you have put in, the filter sizes, dimensions, the nominal airflow of the filter, initial pressure drop, the MPPS. Again, that's a point you can get out of the part 3 of 29463, and usually from the manufacturer, you can add it here. Here you have the maximum integral efficiency of your filter class, in our case H14, and the maximum local efficiency, which is allowed. You have it for information. Here you have basic information concerning the test equipment is what you use, the Pallas LFT 3000 here in that case. Sorry, I can't do it much bigger. And a lighthouse counter starting at 0.1 micron. Aerosol generator, dilution factor. So all the important information is mentioned here. And then you have test conditions. Additionally, here you find the airflow setting, then the test aerosol, the particle size, where the MPPS is, upstream concentration, temperature, and relative humidity. And then we have the results, overall efficiency here, integral upshot, and the minimum efficiency at 95%. So that's this value which is taken in the standard to define the filter class, in our case H14 ISO 45H. Here pressure difference measured was 125 Pascal, so a little bit below the rating, but efficiency was good. So I have here a leak signal value. Leak signal value means that's the number of particles which can locally go through, and the signal distance is more or less how quick that is, how safe that is. That is a value which is based on scanning speed and so on. And afterwards, if there was no leak detected, you get the information that it passed the test and that you have a valid filter classification, which is really now the overall efficiency is okay according to part 5, and the local efficiency is also passed according to part 4. In case we find a leak, you will find the not passed for sure, and then you find how many leaks were detected here. And for sure, as I showed before, you can say, okay, so and so many leaks were detected, and you can go to these points, look for where the leak is, glue it, seal it, and then you can test it again, and you will have the test passed afterwards. So everything is calculated automatically and comes out automatically after the test is finished. So for sure, as Pallas always does, we want to give you the possibility as well to add here manual things. We have a manual test bench operation in case a scanning is activated or whatever. This is blocked, so you can't change anything here. In case no scanning, so no scanning procedure, no test is done, you can manually operate your settings as well, like operating the blower here at different airflows, starting the aerosol generator, switching between up downstream, or indicate local points where you want to see an efficiency. So that is very good for the operator as well. You can check your system always to see what is all there. You can do different tests if you want, and you can evaluate as well at different airflows, for example, maximum concentration of the particle counter. You see here the number of counts which is the particle counter actually measuring. So you can adjust it to come close to its maximum limit. You see here particle size distribution as well. So a very nice point to for the supervisor to see what the test rig is doing and what is reported. So additionally, we offer as well additional tests which are not described now, but are more practical, like a test of pressure drop versus airflow. So you can, same procedure, you can load here predefined settings in 4 different steps. It would set different airflows as seen here. You see here, here's the airflow rate at the moment on display, and here you have the counter pressure at the different points of airflow. So you can have, and for sure with an additional table here, up to 6 points. In case you need more, just tell me. The pressure versus airflow rate display. So more or less, that's the overview of the test bench we created here. I'm very open to talk with you if you have different recommendations, if you have maybe use the chat if you can give us some more tips, what we can do better. But anyhow, I can come more or less to the end of the overview of the leak testing system we have designed, and we would like to discuss with you in case there is any need. So it's a very, very flexible test system. It's a customized test system. As mentioned, we can have larger airflows for you, larger scanning areas for you, smaller scanning areas for you, smaller airflows. Just let us know. We can work with more counters, with less counters. Everything is prepared. And yeah, it's a very quick test. So it's very useful. Local efficiencies are, so we have a high level of modularity, flexibility, and we can do here really successfully different things, different test rigs for you quite easily, because everything is there to cover all what you may need. So we can do the local efficiency test, as said, the scan test. We can calculate overall efficiency. We have an exact localization of the leaks, leak filter detection, and local separation efficiency measuring system can be done, including XY scanning automatic traverse system included for the HEPA filters. Efficiency measurement is usually done from 0.1 to 0.3. The counter itself can go up to 1 micron or 0.5 micron, I think, depending on what you need. On the applications, we can change that. We could work with photometers, for example, that would as well. Just ask us. It's a matter for sure to have a system which is really economic and valid for your needs. It's built-in testing routines. Semi-automatic operation is here just because you have to put in the filter manually, but then the fastening is automatic again, including specific target position measurement, leak visualization, what you have seen already, what I have seen shown you here. It's a very high flexibility, a compact and mobile design, in simple and really intuitive operation. So even I learned that quite quickly. Sorry, it is good. So higher airflows and larger test rigs can be done on request. We can have a wide range of efficiency testing with regards to 29463 part 4 and 5 and part 3. We do also test benches according to part 3 only in case. So we can do it for full elements, for filter materials on requests. We can avoid here, we can have here for these tests ideal flow conditions. We have some measures built in here to cover as well the various filter sizes and still have a representative homogeneous aerosol across the whole filter element area. So highest quality and precision concerning aerosol generation, aerosol measurement, and aerosol transport is implemented. We have the multifunctional software I showed you with predefined measurement procedures. Individual programming for these procedures is possible. Modular setup, flexible configurations are available. And for sure, as said, I'm waiting for your feedback. Pallas provides always international comparable results for salt and oil aerosols here in between. It's a very high repeatability in the testing. I've seen that as well, and the high reproducibility of airflow, pressure drop, and for sure the scanning as well. We can have reduction of measurement time without data losses in increasing the scan speed, but then the local point of leakage may be a little longer to detect, but usually, as I know it, leakage points are not too often there. Flexible software with high detailed content of information is in here. We can have the reporting according to ISO 29463 Part 4, the leak test, and the Part 5, overall efficiency, data transferred and export alternatives like exporting it to text files or whatever is inside there. So yeah, that was more or less my overview. I hope you enjoyed that. Just let us know your needs and we offer the best design for you, and we can do it in a very economic way because we design these test rigs according to the customer's requirements and customer needs. So quite a long thing again. That was 3/4 of an hour, and I will say thank you to everybody who joined that this long. Thank you very much. If there is a filtration standard, we can measure it. Just let us know and we will make it happen. Come to us with your ideas. And in case you have still any questions, and maybe that was too fast or whatever, I have another webinar this afternoon. You can join there as well and listen at that. I would be pleased to welcome you again. But I open the chat now and I will try to answer all your questions in the chat. So until there are questions, I will still be there and trying to answer them right now. Thank you for your participation in case we don't hear us anymore, because I will shut off the microphone to answer now the questions. Yeah, maybe, and I hope you can see it. I put the camera in again. Okay. Yeah, as said, I start with the questions. Have a nice day. Maybe we see us this afternoon again. Thank you for participating. I hope you had a good time and you come back to us and let us know what your needs really are. Thank you. Bye-bye.